times on the side. Inside this box, we have 6 electrical terminals. Each terminal has a corresponding letter and number. We have U1, V1 and W1, then W2, U2 and V2. We have our phase 1 coil connected to the 2 U terminals, then the phase 2 coils which are connected to the 2 V terminals, and lastly the phase 3 coil which is connected to the 2 W terminals. Notice that the electrical terminals are arranged in a different configuration on one side to the other. We will see why that is in just a moment. We now bring in our 3-phase power supply and connect these to their respective terminals. For the motor to run, we need to complete the circuit, and there are 2 ways to do this. The first way is the delta configuration. For this, we connect across the terminals U1 to W2, V1 to U2, and W1 to V2. This will give us our delta configuration. Now, when we provide AC current through the phases, we see that electricity flows from one phase to another as the direction of AC power reverses in each phase at a different time. That is why we have the terminals in different arrangements in the terminal box, because we can easily connect across and allow electricity to flow between the phases as the electrons reverse at different times. The other way we can connect the terminals is to use the star or Y configuration. In this method, we connect between W2, U2 and V2 on only one side. This will give us our star or Y equivalent connection. Now, when we pass electricity through the phases, we see the electrons are shared between the terminals of the phases. Due to their design differences,